Volumetric analysis, also known as titration, is a chemical analytical procedure based on measurement of volumes of fraction in solution. It uses to determine the concentration of a solution by carefully measuring the volume of one solution needed to react with another. An indicator is used to measure the process as it changes in color when the reaction is finished, which indicating the reactant concentration was correctly as predicted. However, application of titration in industry is necessary to check for the correct concentration of ingredients to ensure the quality of products. In quality control, titration provides a method of removing impurities from a sample by selectively reacting with the impurities. Titration is widely used in various industries such as food industry, environmental industry, cosmetics industry, and others for quality purpose. In food industry, titration is used for measuring acid products like vinegar, wine, soft drinks, and dairy products. It is also used for monitoring the concentration of preservative, additive, and flavoring. On the other hand, in environmental industry, titration is used for determining hardness, alkalinity, or dissolved oxygen in water, and analyzing industrial waste for contaminants such as heavy metals and nitrates. Titration also used in cosmetics industry to measure the pH and active ingredients concentration in products like shampoo, creams, and lotion. Hence, it also used for ensuring consistency of products over time. In summary, volumetric analysis plays important role in so many areas, as well as food sector and environmental sector. Among all of the sector, these also involve in chemical producing, looking for oil and gas, and more. Thus, the application of the volumetric analysis has such a wide range which demonstrates its applicability and worth in different sectors.
Theory of volumetric analysis and titration. Volumetric analysis involves determining the concentration of a solution using titration methods. Titration is gradual addition of the solution of non-concentration, titrant, to react with a solution of unknown concentration until the reaction reaches its equivalent points. Equivalent point. The point at which the amount of titrant added is stoichiometrically equivalent to the analyte in the sample. For example, in an acid-base titration, this is when the acid is completely neutralized by the base. Point. The point where the indicator changes color, signaling that the reaction is complete. For example, phenolphthalein changed from colorless to pink at the point during an acid-base titration. Indicator. A chemical compound used to visually identify the endpoint of titration. For example, phenolphthalein change color from colorless to pink between pH 8.2 to 10. Methyl orange change color from red acidic to yellow basic.
For methodology, first need sample preparation such as fruit juice, oils, or processed food, and prepare samples by diluting or filtering. Second, we need select of analytical methods. It can be performed by acid titration, argentometric titration, or redox titration, and alkalimetric. And third, we need to set up bulk titration with clean burette, pipette, and conical flask. 4. Endpoint detection, which use appropriate indicator based on the reaction types. 5. We need to performing titration by adding titrant slowly and record the volume of titrant at the end of the point and repeat it. 6. We do a calculation. There is some specific experiment in CHM256, which is acid-base titration, determine acidity in juice, argentometric titration, salt content in processed food, redox titration, vitamin C content in fruit. For conclusion, volumetric analysis is a vital tool in the food industry, providing precise and reliable method to quantify various components such as acidity, salt content, and vitamin level. By employing titration technique like acid-base, argentometric, and redox titration, Food scientists can ensure product quality by meet regulatory standard and verified nutritional claims.